So the reason that it's all about probability and where we find the electron is because like waves, electrons, or I'm sorry, like light, electrons have properties of waves. And since they have a mass, they also have properties of a particle. So those two things, properties of a particle and properties of a wave, this dual nature makes it impossible to trace an electron's path. So that's why it's all about probability. Because of this dual nature that the electron has, it makes it super complicated. So Schrodinger, he came up with this complicated math. He actually calculated the hydrogen atom, and he came up with the regions where the electrons could be located. So we're not going to get into all that and the math. We're just going to simplify these quantum numbers that he came up with. So the quantum numbers, which we're not going to do, we're just going to talk about, give us an idea of where the electron is. And he told, in Schrodinger's math, he told us that the electron is located in an orbital, not in an orbit. So circle that word orbital, because that's really important. So the lowest energy possible is a 1s orbital. So remember, the electrons like to be in the lower energy states. They don't like to be in an excited state. They're not stable. So we're going to be looking at the principal quantum number, which is the same thing that Bohr was using, the n equal to 1, n equal to 2. So the principal quantum number tells us what energy level we have. So 1 is the lowest, and then as we get higher, the energy increases. So we're going to be using the principal quantum number, which we call the shell, and then we're going to be also using the subshell to tell us the shape of the orbital that the electron is in. And there are 4 possible letters for the orbitals. There's S, P, D, and F. Now we're not going to cover F. We are going to cover a tiny bit of D, but mostly we're going to stick with S and P. Okay, so, but first of all, the S subshell has a spherical shape. Looks like, oh wait, sorry. This is the sphere shape. We'll come back to that. I forgot this slide was in there. So all the shells do not have all the subshells. So you can see n equal to 1, the only possible subshell for n equal to 1 is S. That's it. 2, the possible subshells are S and P. 3, we have S, P, and D. 4, S, P, D, and F. Okay, so we're not going to do F. We're also not going to do 4D. But we are going to use 3D. So if you want, you can mark out n equal to 4, you can mark out the D and the F, because we're not going to be covering those. Okay, sorry, let's go back to the F subshell. So it has a spherical shape. So the dots there on the left represent an electron density map. So this is comes from Schrodinger and his calculations. He was able to create these electron density maps of the orbitals to show us where there's high probability of finding an electron. So where there's a lot of dots, there's a high probability there's electron in that region. So the S orbital always has a sphere shape. Okay, and the difference here between 1s and 2s, you can see, is that the 2s is larger. So 1s, remember, is the lower energy level. 2s is higher in energy. And the higher in energy we get, the further we get from the nucleus. So even though Bohr's model was incorrect, we can kind of take that idea. So n equal to 1, whoops, n equal to 2. It's not the best drawing. N equal to 3. Okay, so kind of going back to his model, as I get higher in energy, I get further and further away from the nucleus. So my sphere is going to get bigger and bigger. So basically, the probability shifts away from the nucleus, the higher my shell number is. Okay, so that's the S subshell. The P subshell looks like this, and again, there's those dots, those electron density maps to give us an idea of where the electron's located. And for the P subshell, we have 2 lobes. And there's 3 of them because for the P subshell, we have 3 orbitals. So there was only 1 sphere, so that means S only has 1 orbital, and P has 3 orbitals. And they all look like that with the 2 lobes. And then the same thing here, if I were to compare 2P and 3P, 3 would be bigger, and then 4P would be bigger, and so on. So as we get into that higher shell number, the probability shifts away from the nucleus. Okay, so on your worksheet, number 3, it says how many orbitals are in the following subshell. So we just learned that S contains 1 orbital, P contains 3, and we haven't talked about this one yet, but D has 5. So we're not going to look at D's shapes. Just know that D has 5 orbitals, and we're not going to even talk about F. Okay, so here we have all of our shells and subshells that we're going to be covering, and we can see how they lie compared to each other on energy level. So for 1s, we only have 1 line because that line is representing how many orbitals we have. So S only has 1. So we go from 1s, go up a little bit, and we have 2s's next. Again, just 1 line because there's 1 orbital. And then 2p is next in the energy level, and it has 3 lines because p has 3 orbitals. And then 3s, 3p, but here's where it gets a little different. Instead of going to 3d, 4s is actually next in energy. So it goes 3s, 3p, 4s, and then back over to 3d. And again, there's 5 lines there because d has 5 orbitals, and then to 4p. So 4p is as high as we're going to go. We're not going past 4p. So each of these orbitals can hold a maximum of 2 electrons. So go back to your worksheet. Number 4 says, what is the total electron capacity for each subshell? Well, if S only has 1 orbital, then the maximum capacity in S is 2 electrons. And then P has 3 orbitals, so we can put a total of 6 electrons in P. And then D has 10 electrons, or I'm sorry, has 5 orbitals, so we can put a maximum of 10 electrons there. And the Aufbau principle tells us that electrons have to be filled from lower energy to higher energy, because remember, always remember, electrons like to occupy the lowest energy state possible.